Okay, we just saw geometric series, and that was one class of examples of series where we have an explicit formula for what the limit is if it exists. So there's going to be another class of examples, and these are these so-called telescoping series. And instead of taking a look at them in an overly detailed way, what we're going to do is we're going to look at some examples and generalize from the examples. So the example is this one. It's going to be the example where we take the sum k equals 3 to infinity of 1 over the quantity k minus 2 times k minus 1. At first glance, there's nothing clear at all about this example. And before we calculate it, let me point out this starts at k equals 3, because otherwise, right, if we started at 1 or 2, our denominator would be 0, and that wouldn't be okay. So, good. So the series should start at k equals 3, just so that it's well defined. Okay, so there's nothing obvious to do on this example, except there's a nice trick that you know from Cal 2 for dealing with expressions that look like this. And the trick from Cal 2 is partial fraction decomposition. So you might remember from, it's a useful integration trick, but it's useful here for sums as well. Right, so the trick is you write 1 over k minus 2 times k minus 1, right? You write this thing as some constant to be determined over k minus 2 plus another constant to be determined over k minus 1. And we cross multiply, and we end up with, all right, so let me go ahead and draw a little line down here. On the left, we're going to work out the series, and on the right, we're going to do this partial fraction decomposition. Right, so that gives us that 1 equals a times k minus 1 plus b times k minus 2. Right, that's by cross multiplying by that denominator right there. And then if we plug in k equals 1, that gives us 1 on the left equals minus b. And if I plug in k equals 2, that gives me that 1 is equal to a. So what that's telling me is that my sum here is looking like it's the sum from k equals 3 to infinity, right? That's the sum k equals 3 to infinity of, so our a is 1, so that's going to be 1 over k minus 2, and then we get minus 1 over k minus 1. So now we've simplified the expression, and now what we can do is write out some terms of the sum and see what we get. Right? So we're going to write this out. And we're going to write this out as, okay, so when k equals 3, what do we get? We get 1 over 3 minus 2 minus 1 over 3 minus 1. That's from this k equals 3 term. And then we get plus, now when k equals 4, we get 1 over 4 minus 2 minus 1 over 4 minus 1. And then we get plus. Okay, when k equals 5, we get 1 over 5 minus 2 minus 1 over 5 minus 1, and so on and so forth. And here we notice some very convenient cancellation, right? 3 minus 1 is the same as this 4 minus 2. 4 minus 1 is this 5 minus 2. So these terms are going to cancel off in pairs, and it's going to go that way for all the terms in our series. And so this is going to give us 1 over 3 minus 2, which is equal to just 1. So that is what we call a telescoping series. And the reason it's called a telescoping series is that it's making reference to a, if you imagine the kind of telescope, right, like imagine a pirate telescope. I wish I had one as a prop. But you have this telescope that you can fold up and it just collapses together. Or people refer to other objects that fold up like that as telescoping. I have telescoping legs on my tripod. It's too big for me to show you in this video. But the idea is that terms in the series cancel each other out pair by pair. So to make that a little bit more formal, let's write down, formally speaking, what it is. And right, the formal case is going to be really simple, whereas the examples are actually going to be a little bit sneaky, and you have to figure out what's going on. Okay, so the formally speaking, the formal picture is that we can write an as being some sequence that's, let's say, a difference of two terms like that, and then the sum, so the partial sum of the series, this is just going to be the sum from n equals 0 to k of bn plus 1 minus bn. Right, so that's what we did in our previous example, where we identified the terms of the sequence as being a difference of two subsequent terms in a different sequence. And so this one becomes quite simple. This becomes, right, that's b1 minus b0 plus b2 minus b1 plus b3 minus b2, and so forth. Right, so that's, you see a bunch of cancellation, and then finally what the last term we get is going to be bk plus 1 minus bk. So that's going to give us b, let's see, who doesn't cancel? I believe we get, then at the end, we get minus b0 plus bk plus 1. Right, so that's an example of what's going on in the telescoping series. And then what, in practice, of course, the tricky part is identifying this alternative sequence bn. But that's precisely what we did in this example when we did the partial fraction decomposition.